Welcome to Chade Hydrogen podcast.
Hello, and welcome back to Chade Hydrogen podcast. I'm Daniel Chade, and I'm glad you're here. Hydrogen has never had more money behind it, more policy support, or better technology than it has right now. And the list of cancelled projects has never been longer. Around 60 major projects were cancelled in 2025 alone. Nearly 5 million tons a year of capacity that simply stopped existing. So, this episode asks the obvious question and then gives an answer most of the industry would rather not hear. Why do hydrogen projects fail? Almost none of them died of physics, they died of decisions. What I want to do today is to walk through 8 ways a good technology gets killed. 4 strategic, 4 executional. And then what the projects that survive consistently do differently. And I want to be clear about where this comes from. This is what I've seen from inside of R&D teams. Let me put the core idea on the table first, because everything else follows from it. Let me frame it with 3 numbers. The first, less than 10% of all of the hydrogen capacity that has been announced has actually reached a final investment decision. Think about that gap between the press release and the steel in the ground. The second, costs tend to land around twice what the model assumed, and they land there at a very specific moment, the moment a prototype meets real manufacturing. And the third number is 0. All of the failures I have looked at closely, none of them was caused by the science not working. Here is the point underneath all 3. Every failed project I've reviewed had a reliable technical story. What they didn't have was a decision structure, a clear answer to who chooses the market, who is allowed to say no to scale up, who owns the cost curve. Technology risk is the risk everyone is comfortable discussing in a board meeting. It's almost never the one that kills you. Here is the map for the rest of the episode, 8 failure modes, and I will name them quickly now rather than explain them, because the rest of the episode does that work. The top row is strategy, wrong market, scaling too early, wrong team for the stage, certification treated as paperwork for later. These decisions get made early, quietly, usually by people who don't think they are making a decisions at all. The bottom row is executional. And in a way, it's worse because these are visible. Everyone can see that design can't be manufactured, that the money is going into the wrong proof, that the offtake letter isn't a contract, that the model only closes with a subsidy. They get ignored anyway. So, the strategic ones you cannot see, the executional ones you refuse to. And one more thing before we start. Every case I'm going to use is public, named companies, published numbers, sources on screen at the end, nothing anonymized, nothing interfered. Failure number 1. The most expensive decision in a hydrogen venture is usually the first one and is often made in an afternoon. The markets get chosen because it's exciting or because a grant call named it or because a founder came from that sector. What almost never happens is a real competitive comparison. Here is the error. Teams compare hydrogen to the market as it exists today, but you're not shipping today. You're shipping in 5 years against an alternative that has a 5 years more of cost reduction and learning. The batteries did not stand still, and I want to be precise about what does it mean. It's not that the battery track won on performance. It's that the whole battery ecosystem, the cost curve, the charging network, moved faster than hydrogen's refueling and fuel cost ever did. Hyzon is an illustration of this because the market choice went wrong on its own terms. And here is the thing to be careful about. Their tracks broadly worked. This wasn't a case of battery tracks winning some head to head performance tests. What beat them was the ecosystem around the track. On the battery side, costs kept falling and charging kept spreading. On the hydrogen side, refueling stayed thin and the fuel stayed expensive, so demand never came loose from subsidies. At launch, they talked about 40,000 trucks by 2025. Across roughly 4 years, they delivered order of the 16. Cash was burning at close to $10 million a month. And when incentive programs like California's voucher scheme started to look uncertain, customers slowed down or paused their orders outright. In February 2025, with no funding and no buyer, the company was simply dissolved. Now, in fairness, Hyzon did settle with the SEC over stated orders, so it isn't spotless either. I won't pretend it, but notice the difference from a case like Nikola. Here is the infrastructure and the economics doing the killing, not the founder's fraud. The product broadly worked, the market underneath it, the fuel, the test station, the costs did not. And if you want the institutional version of the same finding, Francis Kerr, the Compt, reviewed 9 billion euros of hydrogen spending and put road transport abatement at around 520 euros a ton of CO2. The recommendation was to move the money to direct electrification. So, what's the test that prevents this? Name the incumbent. Name its cost in the year you actually ship. Ask what has to be true for hydrogen to win that comparison. And then ask honestly how likely that is. If the answer is a carbon price that nobody has legislated, you don't have a market, you have a policy bet. That can be a perfectly legitimate strategy. It just has to be conscious one. Failure number two, and this is where the real money has died. It's always the same chain of events, so let me walk through it. First, the pressure, and it comes from outside. A round to raise, a grand milestone to hit, a government announcement to make. Someone commits to a gigafactory before the stack design is frozen. Then the commitment hardens, tooling gets ordered, supply agreements get signed, the design is now expensive to change. Then the discovery. Testing does what testing does and finds something the lab never saw. And the fix requires changing the thing you just frozen. And the outcome. A factory built for a product that no longer exists and no capital left to build the right one. Fortescue is the case here, and it's instructive because they were not naive. They abandoned Gladstone in Australia and 80 megawatt plant in Arizona after taking final investment decision, around $150 million. Note what post FID means. The board had already said yes. Earlier, the same company cut 700 jobs and let Gibson Island 550 megawatts die after missing 3 separate final investment decision deadlines. So here is the distinction that matters. Scale up is a consequence of having a stable product. It is never a strategy for getting one. Teams reverse those two things and it's fatal. And the question a board should be asking isn't, can we build a factory? Everyone can build a factory. It's, has this design survived a run long enough to reveal what breaks? If nobody can answer that with data, you are not ready, whatever the funding round promised. Failure number 3. This one is about people, and it's the one that actually hurts. Read the table across because the point is the movement. In the invention phase, you want curious generalists, and you measure them on insight per experiment, how much you learn per unit of money. In the middle phase, you need systems and test engineers and measure changes completely. Reproducibility. Does it do the same thing twice? In deployment, you need manufacturing quality people measured on yield, margin, and uptime. Now the traps. Hiring for a scale you don't have yet, bring in a VP of manufacturing at TRL3 smothers the exploration. Promoting your best scientists into managing people because that's the only reward structure you have loses you a scientist and gains you an unhappy manager. And keeping a founding team that resents process past the point where process is survival. ITM Power is the entire slide in one company, and it's remarkable because they said it themselves. In their interim results, the chairman, Sir Roger Bone, wrote that the company had underestimated the competencies and capabilities required to scale up and to transition from R&D company to a volume manufacturer. The consequence, a 54.1 million pound EBITDA loss on 2 million pounds of revenue. Headcount cut by 25%, and the incoming CEO naming the causes and overly optimistic recruitment program and immature engineering processes. And I want to give ITM real credit here. Most companies never say this loud. They did in their own published results. Because here is the thing about the failure. Nobody in that picture is bad at their job. They are excellent at the job the company no longer has. That's exactly why it's so hard to fix. It feels like betrayal, so it gets postponed. And postponing is what kills the company. Failure number 4. That is glamorous one and one of the most common. The pattern, the team treats certification as something the compliance people handle at the end. By the time it arrives, the standard has become a constraint on a design that can no longer accommodate it. And then the choice is a redesign nobody budgeted or a product nobody can sell. 4 things to understand here. First, the standard is a specification. Safety, materials, and pressure standards dictate geometry, clearances, material choice. Read them while the design is still soft. Second, certification takes about a year and it is not compressible by working harder. Testing documentation, notified body cues, model it as a schedule, fund it as a cost. Third, green is a legal test, not a chemical one. The RFNBO rules on additionality and temporal correlation decide whether your molecule qualifies, which decide whether you have a customer at all. And fourth, the rules move. The regime you design for is not the one you certify under. So try to put your most expensive engineering into the part the regulator is still arguing about. The European Hydrogen Bank makes this point better than any argument I could make. Deutsche Regas pulled 210 megawatts at Lubmin, citing delays to national legislation. Zivong, 560 megawatts, backed by Vattenfall and Copenhagen infrastructure partners, serious people with serious money, forfeited its grant over permitting and delivery milestones. Catalina handed back a first auction grant because it depended on a pipeline that hadn't reached financial close. Not one of those is a technology problem. So here is the line I would leave you with. In hydrogen, The certificate is not evidence that the product works, it's the thing that makes the product sellable. Failure number 5. And this one is my home ground, so forgive me if I linger. Look at the shape of that chart. Cost to come down from the hand-built lab cell through pilot batches into a first production run. And then there is a jump to the number in the business plan with no bar connecting it to the others. The last gap isn't a projection, it's a hope. So why doesn't the last step happen? 4 reasons. The best performing cell was made by your best technician by hand on a good day. That's a record, not a product. The scale cost assumes a yield nobody has demonstrated, using a process nobody has run. Materials picked for lab performance sometimes have no supply chain at volume, at any price. And a design optimized hard for one metric is usually optimized against manufacturability. The IEA Global Hydrogen Review this year puts global electrolyzer manufacturing capacity at 58 gigawatts a year. Actual output in 2025 under 5 gigawatts. That's around 9% utilization, and it was 10% the year before, so it isn't improving. The factories got built, the products did not. And ITM again, on this specific point, from their own postmortem. Constant design changes led to unwelcomed inventory write-downs. This is precisely what an unfinished design does to a factory. The fix, though is genuinely cheap, put a manufacturing engineer in the room at TRL 4, with the objections are still free. At TRL 7, the same objection cost you a redesign. One honest note on that chart, it's illustrative and indexed. It's not a cited dataset, and I would rather tell you that than let it pass. Now, 3 failures at once because all share a common thread. All of them look like commercial progress. That's exactly why they survive scrutiny. Nobody challenges a closed round, a signed memorandum of understanding, or a model that returns a good internal rate of return. Failure 6. Funding before fit. It looks like a race closed, runaway extended, headcount up. What it often actually is, capital spent proving the thing that was easiest to fund, rather than the thing that was the riskiest. A bigger stack, a higher efficiency, a longer test, while the question of who pays and why stays politely open. Topso paused a $400 million electrolyzer factory in Virginia in October 2025 on weak demand, and their 5 gigawatt SOEC reservation with first ammonia terminated in March. A reservation was never a demand. How to fix that? Fund the riskiest unknown first, not the most fundable one. Failure 7. Offtake assumed. It looks like an MOU, a letter of intent, a logo on the slide. What it actually is, a statement that someone is interested if everything goes well and the price is right. No penalty, no commitment, and it will not survive a change of management on their side. The scale of this is remarkable. Around 60 major projects cancelled in 2025, 4.9 million tons a year. Under 4% of the 520 gigawatts announced to 2030 is actually in construction, and there is only 3.6 million tons a year of binding offtake in the entire world. And that the customer has actually committed to. If the honest answer is nothing, you have interest, not demand. And failure 8, subsidy as business model. The model closes, the IRR works, the grant is approved, but the case exists only while the support does, and political timelines are much shorter than industrial ones. The subsidy will change before the asset is paid off. The EU Hydrogen Bank's second auction is the perfect natural experiment. 15 winners were invited to sign. 7 of them withdrew rather than post a completion guarantee, which is 8% of the grant. 993 million euros awarded. 270.6 million actually signed. Asked to put up 8% of their own money, 3/4 of the awarded capacity walked away. That tells you exactly what those bids were. The fix: run the model with the support removed. If it dies, that's not a footnote. That's your primary risk. So let me be clear about what we actually do, because the honest version is this. Most of these failures are preventable, and they are preventable cheaply, but only early. After the tooling is ordered, advice is just commentary. We work with universities, startups, and investors to find these failure modes while they are still cheap to fix. And here 4 things. Technical due diligence, independent assessment of electrolyzers, fuel cells, and deep tech. What the datasheet omits and what the cost curve quietly assumes. Market and failure mode review, the honest competitive test. Who the incumbent actually is, and what has to be true for you to beat it. 3. Organizational staging, structure, roles, and recruitment match to the TRL you're entering, rather than the one you just left. And funding strategy, national and EU instruments, consortium building, and the model that still stands up with the support removed. Quick note on this one, and I will let you go. Every case in this episode is public. Nothing is anonymized, nothing secondhand, nothing infrared. The sources are on screen if you want to check any of it, and I would encourage you to. If I had to point at one ITM power, a chairman naming the failure in his own annual results, that's not my analysis, that's theirs. Projects don't fail, decisions do. That's the whole episode in 2 sentences. Every single failure we've talked about today was a choice, made by capable people with good reasons at the moment when the alternative was uncomfortable. Nobody in any of these stories was stupid. That's what makes these failures repeatable across the industry. And it's also genuinely what makes them preventable. That's the work we do at Chade Hydrogen. Independent, vendor-neutral advice for exactly these decisions. No technology to sell you, no conflicts of interest. So if you're somewhere in the middle of one of those 8 right now, and you would rather hear it from someone today than read it from the postmortem, come and find us at chadehydrogen.com. And one more thing, which I mean sincerely. If you think one of my 8 is wrong, tell me. I just spent a slide recommending you keep someone around who is paid to argue the other side. It would be a poor look if I didn't want to one myself. Thank you so much for spending this time with me, and remember, the technology is almost never the reasons, the decisions are. Until next time.
Chade Hydrogen says bye-bye.